Look up at a clear night sky. The sheer volume of stars stretching out into the dark makes the cosmos feel like a permanent fixture. It is easy to assume that the universe simply is and always will be. But that permanence is an illusion. Reality operates on a ticking clock. Every star will eventually burn out, every galaxy will dissolve, and the universe will arrive at a terminal, absolute end. The foundational laws of physics, the same mathematics that govern gravity and light, calculate this expiration date. Cosmic death is a baked-in requirement of our physical reality. When we measure a human lifespan against a timeline that eventually zeroes out, the significance of our brief existence takes on a very different scale. We are looking at the final destiny of everything. Out of all the ways reality could collapse, the most statistically likely outcome is the heat death. This process is driven by the ongoing expansion of the universe, which is stretching the distance between galaxies wider every second. Trillions of years into the future, this expansion will have pulled matter so far apart that the raw gas required to ignite new stars will be completely exhausted. One by one, the lights of the night sky will simply turn off. This diagram shows the final evolution of matter. After the last stars collapse, even black holes eventually dissolve. Through Hawking radiation, they slowly bleed their mass into the dark, leaving behind a freezing, uniform soup of dormant particles. There is no cinematic explosion in this scenario. Reality simply runs out of energy, ending in a silent, eternal whimper. This diagram illustrates the cosmic tug-of-war. Gravity pulls matter inward, while dark energy pushes space outward. In the Big Rip, dark energy accelerates and overpowers gravity. The expansion becomes so violent it shreds galaxies, solar systems, and finally, your very atoms. But if the density of the universe is high enough, the opposite happens. Gravity wins the tug-of-war, causing the expansion of the universe to stall. This leads to the Big Crunch. The outward drift slams into reverse, rushing everything back together until the entire cosmos is crushed into an infinitely hot, dense singularity. Whether we are shredded by expansion or crushed by gravity, our ultimate fate depends on the final balance between these two invisible forces. There is a third ending that ignores these long timelines entirely. It's called vacuum decay. It relies on the Higgs field, the field that gives matter its mass, being fundamentally unstable. A random quantum fluctuation could trigger a collapse into a true vacuum, creating a microscopic bubble of pure destruction that instantly begins expanding outward. Because this bubble moves at the speed of light, you would never see it coming. It would overwrite the laws of physics as it passes, deleting the Earth, the Sun, and the stars in a fraction of a millisecond. Vacuum decay suggests that existence itself is precarious, balanced on a foundational instability that could trigger at any moment. To understand the timing of these events, we have to look at our own star. This image shows the intense energy of our sun, but in 5 billion years, it will exhaust its hydrogen fuel and swell into a massive red giant, boiling away the Earth's oceans. This expansion will sterilize the planet. If our descendants still exist, they will be forced to abandon their home and seek survival among the stars. By 100 trillion years in the future, the fuel for all stars will be gone. The last red dwarfs will flicker out, and the universe will go dark. This diagram shows the scale of the dark era. Between now and 1 Google years in the future, we witness proton decay and the total evaporation of black holes. Eventually, the very concept of time becomes mathematically meaningless. On this timeline, the entirety of human history occupies less than a millisecond. Humanity's final descendants will huddle around the fading warmth of a dying red dwarf star, watching the lights of the universe turn off one by one. This raises a final question. Could intelligence survive the death of its reality? Freeman Dyson proposed that in a cooling universe, advanced intelligence could survive through infinite hibernation. By slowing their consciousness down to match the cooling cosmos, they could theoretically process an infinite number of thoughts using a finite amount of energy. But survival within this reality remains impossible if space itself rips or crunches. Our only hope would be mastering quantum gravity to punch through space-time into a parallel universe. Until then, we are passengers on a doomed ship. However, this inevitable decline defines the era we live in now. We happen to exist in a high-energy sliver of time where stars are still burning and the ingredients for life are abundant. The finite nature of the void makes this current window of light a rare biological miracle. The stars will eventually fade, but until they do, we have the light, and we have each other.